Hello and good morning, everyone. Welcome to this presentation. In the next half an hour, I'll walk you through some of the features in QGIS 3D. The exciting bits already Kurt has covered, but I try to add some more context. I'm Saber from Lutra Consulting. We are one of the core developers of QGIS in the past 12 years, and some of the features you work with we have developed, so if it works well, it's us. If it's crashing and gives you problems, it's also us. Blame us. We also have a mobile app, which my colleague will talk after that, based on QGIS. Okay, the first part, point clouds. Since in 2022, we started a crowdfunding campaign to include point clouds or LiDAR data inside QGIS. We teamed up with two other open source companies, North Road and Hobu, to do this task. The main problem was really finding the right time zone in Europe, North America, and Australia to have a meeting to talk. But eventually we got there. The initiative, the whole idea behind that crowdfunding was based on feedbacks we had from the community. This LiDAR data was lacking in QGIS. There were some third parties and some tools that did conversions, but there was no native tool in QGIS. Also, there were some open source tools to open LiDAR data, but on the other hand, you couldn't overlay it with the rest of your GIS data like vector, raster, web services. So we thought it would be good that QGIS, which is a very generic desktop application, to have this feature. We prepared a proposal and put it to the community, and they generously funded our work. The first one was to integrate the visualization, the PDAL library. It was in 2020, and we successfully raised enough fund to do that. Then again, we had lots of feedback from community to add more tools like elevation tools and some more visual effect when they load data, and we had another crowdfunding, 81,000 euro, and that one was successful as well. Then the last one, which I'll focus on, it's the introduction of point clouds processing framework in QGIS, which was done late last year, October, November, and now, as of the new release of QGIS 3.32, it should be available. Oops. Oh, I broke the whole thing. Oops. What did I do? Last tab? Okay. Point cloud data are okay, good, yeah, that's the one. These are some examples of point cloud data. In this case, you will see over 1 billion points covering a large area and with different categories, classifications, and then another example is the mobile scanning data. This is from Vienna. And last example, it's, for God's sake, oh, okay. It's large point cloud covering Sydney, I think. These are all visualized in QGIS. And to get there, things we had to overcome was handling large amount of data. The common file format for point cloud is LAS. These are very good for storing data, but they are not optimized for visualization and processing. So we did in the behind the scenes some indexing. When you load the data for the first time, it does some indexing and creates some files. Then it reads those more efficiently, and you can visualize large areas. Point clouds have got lots of data behind it. In this example, you have classifications, different land use. You can easily in QGIS load the data and show those classifications. Another type of data, it's the Z. You can have the symbology, the renderer set based on your elevation data. So you can create some impression of your digital elevation model. And then some of them have got RGB, and you can see it similar to aerial photography. Also, in addition to 2D, you should be able to visualize that all in 3D as well. Then to improve the visualization, you have also the dome lighting, so you can easily identify the features. This is without, and the other side is with. You can see easily how what features you have. Another one, both eye doming works in 2D and 3D. Then ambient occlusion. You can easily identify trees, for example, by having this feature. Then ordering of your points. In this example, if you look at this part, for example, you can't, the black dots now reordered, and you will see proper roof of your building, and the order changed from bottom to top. The other improvement, as Kurt mentioned, we have now classifications plus the percentage of the points, so you can see for each class what percentage of points you have. Also, you can see the non-standard classes here as well. Filtering, if you have a large point cloud and you want to see a specific filter, a specific class, similar to vector data in QGIS, you can apply a filter and do it based on classes or based on elevations, etc. You can easily filter those, and once you apply it, your map will just show the result of the filter. Another useful tool is to have this 2D renderer to follow your 3D. When you set the scene in 2D, it used to be the fact that when you go to 3D, you have to apply all the settings to the 3D, but by having this, they both show the same thing in different map. Another one, showing the point clouds as surface, that's it fills the holes. Also, one of the challenges were the size of the triangles. If you have very steep triangles, you can filter those, and it skips the triangulations for those odd ones. Export to file. Everybody loves shapefile, so why not exporting point cloud to shapefile? And with this feature, you can both export and filter the data on the fly, and also set the attributes you want to export. And there are some tools that unfortunately don't support point cloud directly, and the clients want the point cloud in DXF, or shapefile. This is a way to convert them. And then cloud optimized point cloud. As I mentioned, LAS files are good for storage of data, but they are not very optimized for displaying and processing large data sets. So there is a standard COP-C, and similar to GeoTIFF, when you create a cloud optimized, it creates an indexed, and you can easily either stream the data over a URL, or you can just have it locally. Then it will be much easier for your client to visualize or process the data. And we were one of the first software applications, QGIS 3.26, to opt for this format. This is an example of using it as a file, or you can just point it to your EPT or COP-C. And if you are a data provider, you want to cover a large area by streaming the data to your user's desktop. They don't need to download gigabyte of data to find what area they need. And also, it will be fast to process from the client side as well. So this is an example of a LiDAR data. This is EPT, the predecessor to COP-C, and it's easily visible in can be visualized in QGIS. Point cloud processing. We base the processing on PDAL. PDAL is similar to GDAL library, but for point cloud, it handles read and write of data. Also, it has some processing tools, but it's slightly different to GDAL. Instead of having standalone processing, you have filters, and it has got a Lego approach. So you need to create pipelines by putting those filters together, and to create a pipeline, for example, to create a DTM out of your point cloud. It gives you ultimate flexibility, but to integrate it into QGIS as a desktop user, they don't want to handle this kind of scripting. Also, the parallelization is done by user within the scripting, but for desktop user, again, it will be a hurdle. What we did, we wrapped up all those functionality in a new tool called PDAL Wrench, and it does create a script, for example, in this case, to convert your point cloud to a boundary. And you can run it either from terminal, your shell, or it's integrated within QGIS as a processing tool, and you can run it from there. It also automatically handles the multi-processing, the parallelization based on the number of CPUs you have, so you don't need to do any manual work on that side. And by doing that, we have got this list of processing tools in QGIS in 3.32. It's the starting point. It might not look very comprehensive, but it's the building block that you can in future add more and more filters and pipelines from PDAL, so that the framework is there. I give you examples of some of them. This is the clip by polygon. So you create you have got a point cloud input layer and a polygon, and run it, and it produces the clipped version. Density, you can create a density of your point cloud where you have got high number of points and low numbers, and then filtering by expressions, so you can filter the input data based on expressions similar to the one I mentioned earlier. And this one creates boundaries. So for example, you can create boundaries of your buildings, trees. And then the popular one is to export it to raster. So you can create elevation models out of your point cloud data. And there are some others like thinning. So if you have a very large coverage of the point cloud and you want to have a resampled version to give an overview, you can create a thin version of that. You can export that as a vector layer. You can merge data and also tile data. So if you have a large coverage, again, you want to have them in 100 meter by 100 meter or kilometer by kilometer, you can do that. Fixed projection, conversion, they are self-explanatory. And the more exciting one is virtual point clouds. It's when you have lots of large data similar to GDAL virtual raster, we have adopted virtual point cloud where you reference several LAS files, and then the format of it is based on Stack API, so each of those will become an item collections. You can, if you have a Stack compliant software, you should be able to do it similar to the one to COPC viewer. And it can reference local files and remote files. Then you can load it in QGIS, visualize all the coverage of your point cloud. As you zoom in, the point clouds will appear. Also, the beauty of this is you can do all sorts of processing I mentioned beforehand. Let's say you want to clip the data or create DTM of large data. You can easily load the virtual point cloud for a country and then just select an area and clip the data or create DTM in a specific area. So this the visualization is also available in 3D. This example with 37 billion, and it's smooth because the data is streamed and you can easily see the data. Okay, I'm running out of time, so I quickly go through the 3D improvement. Kurt has mentioned most of them, but one that it's available now, it's measurements in 3.32 or global. Okay, this one is 3D measurement, so you can smartly move around and measure buildings in 3D scenes. It nicely snaps in on your objects, and you have measurements in X, Y, and also Z. And I give you a preview of some of the upcoming features. Confirmed works in QGIS 3.36. We will introduce point size renderer, so you will be able to change the size of point cloud based on some attributes. You can also see the point clouds as a surface in 2D maps. In QGIS 3.34 later this year, we will have support for 3D tiles that's funded by Cesium. So you can create those nice Google Earth type of things inside QGIS. And also, if you want to bring across some of those interesting PDAL pipelines for filtering and noise reduction, classification, the framework is there, and we should be able to introduce that easily. So come and talk to us.